Hello everyone. Welcome you all back to my channel, and today we are discussing on the part 2 of computer networks and networking. So let's get started. So topics for today's session we have switching technology, OSI model, TCP/IP protocol suite, network performance, and last we have the summary for today's session. So switching technology. What exactly is the switching technology? It is basically a technique for transferring the information from one computer network to another network. Switching in a computer network is achieved by using switches. Here you can see one of the small image architecture I have mentioned. So in this, multiple switches are connected with each other, and through those switches, the devices, the end users' systems are get connected. A switch is a small hardware device which is used to join multiple computers together with one local area network. Well, when we connect the multiple devices and creates a small network that is called as the LAN, local area network. That particular network is created locally. That is the reason it's called as the local area network. Switches are the devices capable of creating temporary connections between two or more devices linked to the switch. Switches are used to forward the packets based on MAC addresses. A switch is used to transfer the data only to the device that has been addressed. It verifies the destination address to route the packet appropriately. It is operated in full duplex mode. It does not broadcast the message as it works with limited bandwidth. Now, there are certain advantages and disadvantages of switching. So, as per the advantages of switching, switch increases the bandwidth of the network. It reduces the workload of individual PCs as it sends the information to only that device which has been addressed. It increases the overall performance of the network by reducing the traffic on the network. There will be less frame collision as switch creates the collision domain for each connection. Now, the disadvantages are a switch is more expensive than network bridges. A switch cannot determine the network connectivity issues easily. Proper designing and configuration of switch are required to handle multicast packets. So there are certain switching techniques we have. There are different types of switching techniques. So here you can see one hierarchical structure in which switching techniques has been divided into different types of switching, like circuit switching, packet switching, and message switching. And packet switching is also subdivided into two different switching methods, that is virtual circuit approach and datagram approach. Now, circuit switching. Circuit switching is a switching technique that establishes a dedicated path between sender and a receiver. In the circuit switching technique, once the connection is established, then the dedicated path will remain to exist until the connection is terminated. Circuit switching in a network operates in a similar way as the telephone works. A complete end-to-end path must exist before the communication takes place. In case of circuit switching technique, when any user wants to send the data, voice, video, a request signal is sent to the receiver, and then the receiver sends back the acknowledgement to ensure the availability of the dedicated path. After receiving the acknowledgement, dedicated path transfers the data. Circuit switching is used in public telephone network. It is used for voice transmission. This is one of the valid points. It's used for the voice transmission. Fixed data can be transferred at the time in circuit switching technology. It transferred at a time. There are different phases of circuit switching. Basically, we have three phases. First is called as the connection setup or establishment. In this phase, a dedicated circuit is established from the source to the destination through a number of intermediate switching centers. The sender and receiver transmits communication signals to request and acknowledge establishment of circuits. Data transfer. Once the circuit has been established, data and voice are transferred from source to destination. The dedicated connection remains as long as the end parties communicate. And the third phase is connection tear down or termination. When data transfer is complete, the connection is relinquished. The disconnection is initiated by any one of the user. Disconnection involves removal of all intermediate links from the sender to the receiver. Here we can see one of the architecture, how the circuit switching establishment works from source till destination, from sender to receiver. So here we can see there are four users. They transmit the data which travels through the multiple network devices through the communication network. The sender sends the data, the transmission data, and it gets received by the receiver. Now, there are certain advantages and disadvantages of circuit switching. So, as for the advantage, it is suitable for long continuous transmission since a continuous transmission route is established that remains throughout the conversation. The dedicated path ensures a steady data rate of communication. No intermediate delays are found once the circuit is established. So, they are suitable for real-time communication of both voice and data transmission. About the disadvantages of circuit switching establishes a dedicated connection between the end parties. This dedicated connection cannot be used for transmitting any other data, even if the data load is very low. Bandwidth requirement is high, even in case of low data volume. There is underutilization of system resources. Once resources are allocated to a particular connection, they cannot be used for another connection. Time required to establish a connection may be high. It is more expensive than other switching techniques as a dedicated path is required for each connection. Now, about packet switching. The packet switching is a switching technique in which the message is sent in one go, but it is divided into smaller pieces and they are sent individually. The message splits into smaller pieces known as packets, and packets are given a unique number to identify their order at the receiving end. Every packet contains some information in its headers, such as source address, destination address, and sequence number. Packets will travel across the network, taking the shortest path as possible. All the packets are reassembled at the receiving end in correct order. If any packet is missing or corrupted, then the message will be sent to resend the message. If the correct order of packets is reached, then the acknowledgement message will be sent. Here we can see two of the specified architectural designs, the way the packet used to travel. So you can just pause the video over here and look at the image properly, in which sender sends the data, it gets converted into packet, and receiver receives the data after the packet got re-established. The similar way is being initiated into the different structure. Now, there are certain advantages and disadvantages of packet switching as well. First advantage is it is cost effective. In packet switching techniques, switching devices do not require massive secondary storage to store the packet. So, cost is minimized to some extent. Therefore, we can say that the packet switching technique is a cost effective technique. Second advantage is it is reliable. If any node is busy, then the packets can be rerouted. This ensures that the packet switching technique provides reliable communication. Third advantage, it is efficient. Packet switching is an efficient technique. It does not require any established path prior to the transmission, and many users can use the same communication channel simultaneously. Hence, makes use of available bandwidth very efficiently. The disadvantages of packet switching are packet switching technique cannot be implemented in those applications that require low delay and high quality services. Packet switching, the protocol used in this technique are very complex and requires high implementation cost. If the network is overloaded or corrupted, then it requires transmission of lost packets. It can also lead to the loss of critical information if errors are not recovered. There are certain parts we have seen in the hierarchy. There are two different types of packet switching. One is approaches of packet switching and another is datagram packet switching. Under approaches of basically the packet switching has been approached into two different approaches. One is called as datagram packet switching Another is virtual circuit switching. Datagram packet switching. It is a packet switching technology in which packet is known as a datagram is considered as a independent entity. Each packet contains the information about the destination and switch uses this information to forward the packet to the correct destination. The packets are reassembled at the receiving end in correct order. In datagram packet switching technique, the path is not fixed. Intermediate nodes take the routing decision to forward the packets. Datagram packet switching is also known as connectionless switching. There are no setup or tear down phases. Each packet is treated the same by a switch regardless of its source and destination. Here we can see the architecture of a datagram as we see earlier in the packet switching when we are discussing about that. Uh, in that particular formation, this particular architecture is for the datagram network. In this example, all four packets or datagrams belongs to the same message but may travel different paths to reach their destination. You can see with the numbers these particular packets, the four packets which is also known as the datagrams. They belongs to the same message. Sender sends a specific message, so it get converted into packets. That is also known as datagrams, and they find the different route, different path, so they can reach to the destination accordingly. And based upon that, the specified message which sender has sent for the receives receives at its end. About routing table. In this type of network, each switch or packet switch has a routing table which is based on the destination address. The routing tables are dynamic and are updated periodically. The destination addresses and the corresponding forwarding output ports are recorded in the table. Here you can see one of the small tabular format. There is a router. That particular router is containing a routing table, and that particular routing table contains two things. One is destination address, another is output port. So, whenever any data gets transferred by the sender, so based upon the routing table, it tries to matches the specified destination where it is going to be delivered, and based upon that, the specified destination addresses get circulated and get identified that this particular message belongs to which receiver, and based upon that, the output port sends those packets of data to the destination or the receiver's end, so that receiver gets the same message as the message sent by the sender. Now, there are certain delays in the datagram network. Here we can see one of the architecture. Uh, A is the sender, B is the receiver. When A sends the data, the particular formation which you see in the blue is the transmission time. When the data reaches to the first router, it takes some time, and that particular time is called as the waiting time. When the first router finds the specified destination, that particular router belongs to the sender. Uh, it is from the sender send. So the first router sends that data to router 2. So that transmission also, you can see the transmission is being done with the blue color, and in the receiver's router end, it tries to find out that who is the receiver for the message sent by the sender, and the total time which takes place for the router to find out the receiver's end, that is also called as the waiting time for receiver's end. And once router 2 finds the destination, then that particular data got transmitted and get landed at the receiver's end. So the time frame of receiving a data between the router 2's transmission to the receiver, the space time which is lacking between these two is called as the total delay. Now we can see the specified total delay formations. The packet travels through two switches. There are three transmission times, three propagation delays, which is the slopes 3t of the line, and two waiting times, that is waiting 1 plus waiting 2. We ignore the processing time in each switch. So the total delay is calculated as 3t, that means 3 transmission time plus 3 propagation time plus waiting 1 plus waiting 2. The total calculation of the time creates your total delay. Now, about a different different type of circuit switching called as virtual circuit switching. Now, what is virtual circuit switching? Virtual circuit switching is also known as the connection oriented switching. In the case of virtual circuit switching, a virtual connection is established before the message are sent. Call request and call accept packets are used to establish the connection between sender and the receiver. In this case, the path is fixed for the duration of a logical connection. Virtual circuit identifier. A virtual circuit identifier that uniquely identifies the connection at this switch. A a virtual circuit identifier, unlike a global address, is a small number that has only switch scope. It is used by a frame between two switches. When a frame arrives at a switch, it has a VCI. When it leaves, it has a different VCI. So here we can see one of the structure. A data is got sent from from the source. The particular VCI got generated is 14. When it travels by using the global address, at the destination end, data is received via virtual circuit identifier, but it's having a different number. That is 77. Now, about virtual circuit table. Every virtual circuit maintains a table called as virtual circuit table. One entry in the virtual circuit table on a single switch contains the following: an incoming interface on which packets for this virtual circuit arrive at the switch, an ongoing interface in which packets for this virtual circuit leave the switch, and on an outgoing virtual circuit identifier that will be used for outgoing packets. For example, source A sends a frame to source B to switch 1, switch 2 and switch 3. Now, here you can see that example which we discussed just now. The specified tables, which is also known as the switching tables, and the way the data is transmitting. So, from a sender A, the data got transferred with VCI value 14, moved to switch 1. It calculates through the switching table as the incoming and outgoing. Based upon that, that particular data travels to second switch, in which another switching table got accessed, through which it then moves to another switch via data and the VCI number 22, and from that switch it delivers at the receiver's end with data and VCI value 77. Now, the particular formation which plays between these different switches is known as WAN, which is called as wide area network. Now, there are two different types of virtual circuits. One is called PVC and another is SVC. PVC, that means permanent virtual circuit. Network administrator will configure the state. The virtual circuit is permanent. When we talk about SVC, that is switched virtual circuit. A host can send messages into the network to cause the state of the established. This is referred as signaling. A host may set up and delete such a virtual circuit dynamically without the involvement of a network administrator. Now, delay in a virtual circuit network. The packet is traveling through two switches routers. There are three transmission times, three propagation time, data transfer depicted by the sloping lines, a setup delay which includes transmission and propagation in two directions, and a tear down delay which includes transmission and propagation in one direction. So here we can see the calculation. Total delay is equal to 3 transmission time, 3 propagation time, plus setup delay plus tear down delay. The same you can find in the architecture. Now, there are certain comparisons we can find. When we talk about circuit switching, it is connection oriented. It ensures in order delivery. No reordering is required. A dedicated path exists for data transfer. All the packets take the same path. Resources are allocated before data transfer. Stream oriented, fixed bandwidth, reliable, no overload, no overheads, implemented at physical layer, inefficient in terms of resource utilization, and the best example for circuit switching is telephone system. Now, when we talk about the packet switching, it has two different types of packet switching. One is virtual circuit switching, another is datagram switching. So when we talk about virtual circuit switching, it is connection oriented. It ensures in order delivery. No reordering is required. A dedicated path exists for data transfer. All the packets take the same path. Resources are allocated on demand using first packet. It is packet oriented. It has dynamic bandwidth. It is reliable. It has less overheads. It is implemented at data link layer. It provides better efficiency than circuit switched systems. And the best example for virtual circuit switching is X.25 and frame relay. When we talk about the datagram switching, it is connectionless. Packets may be delivered out of order. Reordering is required. No dedicated path exists for data transfer. All the packets may not take the same path. No resources are allocated. Packet oriented, dynamic bandwidth, unreliable, higher overheads, implemented at network layer, provides better efficiency than message switch system. And the best example for datagram switching is internet. Now we have message switching. So message switching is a switching technique in which a message is transferred as a complete unit and routed through intermediate nodes at which it is stored and forwarded. In message switching technique, there is no establishment of a dedicated path between the sender and the receiver. The destination address is appended to the message. Message switching provides a dynamic routing as the message is routed through the intermediate nodes based on the information available in the message. Message switches are programmed in such a way so that they can provide the most efficient routes. Each and every node stores the entire message and then forward it to the next node. This type of network is known as store and forward network. Message switching treats each message as an independent entity. Here we can see a small architecture about message switching, the way it travels. So you can see the sender sends the data, it moves to the first message switching formation. First it's stored, then it forwards, then again it reaches to another one, another switch where it stores and then forward. Then it moves to the third switch. Then it's stored and forward. After that, it reaches to the fourth switch where it stores and forward. And at last, it's received by the receiver. So it process in a different method. So, for example, we have four machines M1, M2, M3, M4. So in that particular way, uh, In the top we can see M1 M2, in the bottom we can see M1 M2. So once M1 in the top one, when the M1 sends the data, it received by the M1 in the bottom. When M2 sends the data in top, it received by M2 in the bottom. In the same way, M1 can send the data and it can be reaches to the M2 in the bottom. So here you can see the way the message is traveling. So the specified message depends upon the senders and receiver, that that particular message belongs to whom and who sent it. Now we have protocol layering. In networking, a protocol defines the rule that both the sender and receiver and all intermediate devices need to follow to be able to communicate effectively. The protocol provides a communication service that the process used to exchange messages. When communication is simple, we may need only one simple protocol. When the communication is complex, we may need to divide the task between different layers, in which case we need a protocol at each layer or protocol layering. Protocol layering is that it allows us to separate the services from the implementation. A layer needs to be able to receive a set of services from the lower layer and to give the services to the upper layer. Any modification in one layer will not affect the other layers. Now, there are certain elements about the layered structure. So, about the basic elements of layered structure, we have first service. It is set of actions that a layer provides to the higher level. Next, we have protocol. It defines a set of rules that a layer uses to exchange the information with peer entity. These rules mainly concern about both the contents and order of the messages used. And third element is interface. It is a way through which the message is transferred from one layer to another layer. There are certain features of protocol layering. So it decomposes the problem of building a network into more manageable components. It provides a more modular design. The principles of protocol layering are: the first principle dictates that if we want bidirectional communication, we need to make each layer so that it is able to perform two opposite tasks, one in each direction. Second principle is that we need to follow in protocol layering is that the two objects under each layer at both sides should be identical. Now we have a protocol graph. The set of protocols that make up a network system is called as a protocol graph. The nodes of the graph correspond to protocols and the edges represent a dependence relation. For example, the figure below illustrates a protocol graph consists of protocols RRP, that is request or reply protocol, and MSP, message stream protocol. implement two different types of process to process channel, and both depend on the HHP, that is host to host protocol, which provides a host to host connectivity service. So here in the architecture we can see there are two hosts, and specified way the data is generated, like for example file application, digital library application, video application. So that particular file and digital library application relates to the specified request, or it may be initiated as a reply. So both of them connected with RRP. The video application is a kind of a message. So that particular video being the part of MSP. Now, when RRP and MSP both initiated into the things, then they combine together and form with the HHP. Now, from that HHP, that is host to host protocol, the data travels and reaches to the specified network, and then it moves out and forward it to the host to network via the similar process, but it reaches to HHP, and then HHP redistributed that message into two, that is one RRP and another to MSP, and then RRP reinitiate his data to the specified form, that is file application and digital library application, and MSP also distribute its data, that is the video application, and at the end host to receive the complete data. Now I hope you are able to understand and able to grab the things which I discussed with you till now. If you find this video interesting, the topics interesting till now, please go ahead and hit the like button. Do share the video with your friends and families and colleagues, and hit a subscribe button so that you can get more and more videos like this, the informative videos like this. So let's proceed now. Now next we have OSI model. OSI stands for Open System Interconnection. It is a reference model that describes how information from a software application in one computer moves through a physical medium to the software application in another medium. OSI consists of 7 layers, and each layer performs a particular network function. OSI model was developed by the International Organization for Standardization, that is ISO, in 1984, and it is now considered as an architectural model for the intercomputer communication. OSI model divides the whole task into 7 smaller and manageable tasks. Each layer is assigned a particular task. Each layer is self-contained, so that task assigned to each layer can be performed independently. So here we can see the particular 7 layers of OSI model. So from the bottom till top, the layers are physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Now, the particular organization of the OSI layers. So, the OSI model is divided into 2 layers. One is called as upper layer, another is called as lower layer. So, as per the upper layer, it is called as the responsibility of the host. The upper layers of the OSI model mainly deals with the application related issues, they are implemented only in the software. Lower layer, that is the responsibility of the network. The lower layer of the OSI model deals with the data transport issues. They are implemented in hardware and software. So here we can see that particular 7 layers, and the layer from physical layer data link, from physical to network, that is physical layer, data link layer, network layer. These three creates, and these three layers are known as the lower layer, which is also known as the responsibility of the network. And from transport till application, it is the responsibility of the host, that is the upper layer. Now we can see how the specified data get communicated. So the specified data get communicated with end-to-end host technology. So specified way the particular data is created and initiated by different layers accordingly. So we can see there is one or more nodes within the network. So the particular network is initiated with these three layers, that is physical, data link and network. Now when we talk about the organization of the OSI layers, let's discuss about the different layers. So first we have physical layer. So the physical layer coordinates the functions required to transmit a bit stream over a physical medium. The physical layer is concerned with the following functions: physical characteristics of interfaces and media. That is, the physical layer defines the characteristics of the interface between the devices and the transmission medium. Second, representation of bits. To transmit the stream of bits, it must be encoded to signals. The physical layer defines the type of encoding. Next, we have signals. It determines the type of the signal used for transmitting the information. Then we have data rate or transmission rate. The number of bits sent each second is also defined by the physical layer. Then we have synchronization of bits. The sender and receiver must be synchronized at the bit level. Their clocks must be synchronized. Then we have line configuration. In a point-to-point configuration, two devices are connected together through a dedicated link. In a multi-point configuration, a link is shared between several devices. Physical topology. The physical topology defines how devices are connected to make a network. Devices can be connected using a mesh, bus, star, and ring topology. Transmission mode. The physical layer also defines the direction of transmission between two devices: simplex, half duplex, or full duplex. Next, we have data link layer. It is responsible for transmitting frames from one node to the next node. The other responsibilities of this layer are: first, framing. It divides the stream of bits received into data units called frames. Then, physical addressing. If frames are to be distributed to different systems on the network, data link layer adds a header to the frame to define the sender and the receiver. Then, flow control. If the rate at which the data are absorbed by the receiver is less than the rate produced in the sender, the data link layer imposes a flow control mechanism. Then we have error control. It is used for detecting and retransmitting damaged or lost frames and to prevent duplication of frames. This is achieved through a trailer added at the end of the frame. Then, medium access control. It is used to determine which device has control over the link at a given time. Next layer we have network layer. This layer is responsible for delivery of packets from source to destination. It determines the best path to move data from source to the destination based on the network condition, the priority of service, and other factors. The other responsibilities of the layer are logical addressing and routing. So when we talk about logical addressing, if a packet passes the network boundary, we need another addressing system for source and destination called as logical address. This addressing is used to identify the device on the internet. When we talk about routing, routing is a major component of the network layer and it determines the best optimal path out of the multiple paths from source to the destination. Next layer we have transport layer. It is responsible for process to process delivery, that is responsible for source to destination end to end delivery of the entire message. It also ensures whether the message arrives in order or not. The other responsibilities of this layer are first, port addressing or service point addressing. The header includes an address called as port address or service point address. This layer gets the entire message to the correct process on that computer. Next we have segmentation and reassembly. The message is divided into segments and each segment is assigned a sequence number. These numbers are arranged correctly on the arrival side of this layer. Now, next we have connection control. This can either be connectionless or connection oriented. When we say about connectionless, so the connectionless treats each segment as an individual packet and delivers to the destination. When it is connection oriented, the connection oriented makes connection on the destination side before the delivery. After the delivery, the termination will be terminated. Then we have flow control. The transport layer also responsible for flow control, but it is performed end to end rather than across a single link. And last, in transport layer we have error control. The error control is performed end to end rather than across the single link. Next layer we have session layer. This layer establishes, manages and terminates connections between applications. The other responsibilities of this layer are first, dialog control. Session layer acts as a dialog controller that creates a dialog between two processes, or we can say that it allows the communication between two processes which can be either half duplex or full duplex. Another responsibility in session layer is synchronization. So, the session layer adds some checkpoints when transmitting the data in a sequence. If some error occurs in the middle of the transmission of data, then the transmission will take place again from the checkpoint. This process is known as synchronization and recovery. Next layer is presentation layer. It is concerned with the syntax and semantics of information exchanged between two systems. The other responsibilities of this layer are: first, translation. Different computers use different encoding systems. This layer is responsible for interoperability between these different encoding methods. It will change the message into some common format. Encryption and decryption. It means that sender transforms the original information to another form and sends the resulting message over the network and vice versa. Last one in presentation layer is compression and expansion. Compression reduces the number of bits contained in the information, particularly in text, audio, and video. The last layer is application layer. So, this layer enables the user to access the network. It handles issues such as network transparency, resource allocation, etc. This allows the user to log on to remote user. The other responsibilities of this layer are: first, FTAM, that is File Transfer Access Management. It allows user to access files in a remote host. Then, mail services. It provides email forwarding and storage. And last in application layer is directory services. It provides database sources to access information about various sources and objects. Now, here you can see the architecture. So, in the first architecture, you can see the data which is being initiated, one at the sender side, another is the receiver side. So, when sender sends the data from level 1, that is from physical layer, the data start traveling and reaches to application layer. So the process which takes place between application to physical, the formation is known as transmission. When at the receiver side, from application layer, the data travels and reaches to physical layer. So the specific communication which done between physical layer and application layer at receiver side is known as receiving of data. So the process which takes place for sending data from physical layer to application layer is known as encapsulation method. When data travels from application to physical, it is known as the decapsulation method. Now here we can see a different architecture in which the specified OSI model it works accordingly. So here we can see the specified interface and its action. So you can just pause the video here and read the specified architecture, that how the specified data get transmitted. Now, next we have TCP IP protocol suite. I hope you are finding the information informative. If you find the information informative, then please go ahead and hit the like button, share the video with your friends and colleagues, and do subscribe the channel. Now let's continue. TCP/IP protocol suite. So the TCP/IP architecture is also called as Internet architecture. It is developed by the US Defense Advanced Research Project Agency, that is DARPA, US DARPA, for its packet switched network called as ARPANET. TCP/IP is the protocol suite used in the Internet today. It is a four-layer model. The layers of TCP/IP are application layer, transport layer, which contains TCP and UDP, internet layer, and network interface layer. Now, the way the specified TCP/IP protocol suite works, uh, in the bottom, uh, we have created it as a five-layer, but it is actually a four-layer protocol. It's actually a four-layer model. Why five layers? Because the bottom layer is the layer in which the hardware devices are initiated. So once that hardware devices get connected with each other, that creates the network. And through that network, there is a specific interface which is connected to the internet. So our basic formation of TCP/IP protocol suite is application transport, internet, and network interface. So here we can see the specified architecture. You can just go ahead and pause the video here and look into the specified formation, how that transmission occurs. Now we can see different formations. One is for the TCP/IP protocol suite, and another is the TCP/IP model. That means what are the things get done in the specified levels of the TCP/IP protocol, and about the four layers of the TCP/IP model, what are the things and how that get happens, how that works. You can see it in this image. So just go ahead and pause the video here as well and read the things. Now let's discuss about the layers in the TCP/IP protocol suite. So first we have application layer. So an application layer incorporates the function of top three OSI layers. An application is the topmost layer in the TCP/IP model. It is responsible for handling high-level protocols, issues of representation. This layer allows the user to interact with the application. When one application layer protocol wants to communicate with the another application layer, it forwards its data to the transport layer. Protocols such as FTP, HTTP, SMTP, POP3, etc., running in the application layer provides service to other program running on top of application layer. Then next layer we have transport layer. The transport layer is responsible for the reliability, flow control and correction of data which is being sent over the network. The two protocols used in the transport layer are User Datagram Protocol and Transmission Control Protocol. UDP. UDP provides connectionless service and end-to-end delivery of transmission. It is an unreliable protocol as it discovers the error but not specify the error. When we talk about TCP, TCP provides a full transport layer service to application. TCP is a reliable protocol as it detects the error and retransmits the damaged frames. Next layer we have internet layer. The internet layer is the second layer of the TCP/IP model. An internet layer is also known as the network layer. The main responsibility of the internet layer is to send the packets from any network and they arrive at the destination irrespective of the route they take. Internet layer handles the transfer of information across multiple networks through router and gateway. IP protocol is used in this layer and it is the most significant part of the entire TCP/IP suite. And the fourth layer is network interface layer. The network interface layer is the lowest layer of the TCP/IP model. This layer is the combination of physical layer and data link layer defined in the OSI reference model. It defines how the data should be sent physically through the network. This layer is mainly responsible for the transmission of the data between two devices on the same network. The functions carried out by this layer are encapsulating the IP datagram into frames transmitted by the network and mapping of IP addresses into physical addresses. The protocols used by the layer are Ethernet, Token Ring, FDDI, X.25 and frame relay. Here we can see the specified comparison of OSI model and TCP/IP model. So you can just go ahead and pause the video and read the things mentioned over here. Now I can show you, I can read out certain comparison for you. So as per OSI model, it is defined before advent of internet. The service interface and protocols are clearly distinguished before. Internet working not supported. Strict layering, protocol independent stand, less credible. All packets are reliably deleted. When we talk about TCP/IP model, it defined after the advent of internet. Service interface and protocols were not clearly distinguished before. TCP/IP supports internet working, loosely layered, protocol dependent standard, more credible. TCP reliably delivers packets. IP does not reliably deliver packets. Here is another formation of comparison. You can just go ahead and pause here and read the things. Now, next we have network performance. So the network performance is measured by using bandwidth, throughput, latency, jitter, round trip time. When we say about bandwidth, so the bandwidth of a network is given by the number of bits that can be transmitted over the network in a certain period of time. Bandwidth can be measured in two different values, bandwidth in hertz and bandwidth in bits per second. When bandwidth in hertz are there, it refers to the to the range of frequencies contained in the composite signals or the range of frequencies the channel can pass. For example, we can say the bandwidth of a subscriber telephone line is 4 kilohertz. About the bandwidth in bits per second. A bandwidth in bits per second refers to the number of bits transmitted per second. For example, the bandwidth of a network is a maximum of 100 Mbps. This means that this network can be 100 Mbps. About the relationship, there is an explicit relationship between bandwidth in hertz and bandwidth in bits per second. Basically, an increase in bandwidth in hertz means an increase in bandwidth in bits per second. Next is the throughput. Throughput is a measure of how fast we can actually send data through a network. Bandwidth in bits per second and throughput may seem to be same, but they are different. A link have a bandwidth of capital B BPS, but we can only send capital T BPS through this link. Capital T is always less than capital B. In other words, the bandwidth is a potential measurement of a link. The throughput is an actual measurement of how fast we can send data. For example, we may have a link with a bandwidth of 1 Mbps, but the device connected to the end of the link may handle only 200 kbps. This means that we cannot send more than 200 kbps through this link. Here we have one problem and its solution so that it will be easy for you to uh, get to the point clearly. So, as for the problem, a network with bandwidth of 10 Mbps can pass only an average of 12,000 frames per minute, with each frame carrying an average of 10,000 bits. What is the throughput of this network? So we can calculate the throughput as uh, total number of frames multiplied the bandwidth whole upon 60 is equal to 2 Mbps. The throughput is almost one-fifth of the bandwidth in this case. Next we have latency or delay. The latency or delay defines how long it takes for an entire message to travel from one end to a network to another. Latency is made up of four components: propagation time, transmission time, queuing time, and processing delay. So here we can see how latency is calculated. So latency is calculated by propagation time plus transmission time plus queuing time plus processing delay. So here we can see the architecture, how the specified latency works. When we let's discuss about the specified components. First we have propagation time. So propagation time measures the time required for a bit to travel from the source to the destination. The propagation time is calculated by dividing the distance by the propagation speed. The propagation speed of electromagnetic signals depends on the medium on the frequency of the signal. The calculation method of propagation time is equal to distance upon propagation speed. Next we have transmission time. In data communication, we don't send just one bit, we send a message. The first bit may take a time equal to the propagation time to reach its destination. The last bit also may take the same amount of time. However, there is a time between the first bit leaving the sender and the last bit arriving at the receiver. The first bit leaves earlier and arrives earlier. The last bit leaves later and arrives later. The transmission time of the message depends on the size of the message and the bandwidth of the channel. So, the calculation method is transmission time is equal to the message whole upon propagation speed. Next we have queuing time. Queuing time is the time needed for each intermediate or end devices to hold the message before it can be processed. The queuing time is not a fixed factor. It changes with the load imposed on the network. When there is heavy traffic on the network, the queuing time increases. An intermediate device, such as a router, queues the arrived messages and processes them one by one. If there are many messages, each message will have to wait. Processing delay. Processing delay is the time that the nodes take to process the packet headers. Processing delay is a key component in network delay. During processing of a packet, nodes may check for bit level errors in the packet that occurred during transmission, as well as determining where the packet's next destination is. Now, next we have bandwidth delay product. Bandwidth and delay are two performance metrics of a link. The bandwidth delay product defines the number of bits that can fill the link. This measurement is important if we need to send data in bursts and wait for the acknowledgement of each burst before sending the next one. So here we can see uh, the specified way of the calculation from sender to receiver. The sender sends the data, it gets divided into specified bits. Then after 1 second, one bit get reduced. Then after 1 second, another bit get reduced. Then after 1 second, another. Then another, and at last it reaches to the receiver. Next, we have jitter. Another performance issue that is related to delay is jitter. Jitter is a problem that if different packets of data encounter different delays and application using the data at the receiver side is time sensitive, that is audio and video data, for example, if the delay for the first packet is 20 ms, for the second is 45 ms, and for the third it's 40 ms, then the real-time application that uses the packets endures jitter. Next we have round trip time, that is RTT. RTT refers to how long it takes to send a message from one end of the network to the other and back rather than one way latency. This is called as round trip time of the network. Now, let's summarize the session. First, we have seen switching, which connects devices and forwards data efficiently using switches. There are certain major techniques of switching, that is circuit switching, packet switching, message switching. Circuit switching is dedicated path, reliable, ideal for voice communication. Packet switching, data split into packets, efficient and scalable, that is internet. Message switching, store and forward of complete messages. Protocol layering breaks communication into layers for modularity and interoperability, defines services, protocols, and interfaces between layers. We have discussed on OSI model the seven layers, that is physical data link network, transport session, presentation, application. Then we discussed about TCP/IP model, the four layers, application, transport, that is TCP/IP, UDP, internet, IP, network interface. Then we have seen the difference, the comparison of OSI versus TCP/IP model. That is, OSI is the reference model, TCP/IP is the practical internet protocol suite used worldwide. And last, we have seen network performance metrics based upon bandwidth, throughput, latency, jitter, RTT. I hope you find this video informative. If you find this video informative, then please do like, share and subscribe the channel. And if you have any question, then type the same in the comment box below to get the answer. Thank you and have a nice day.